Hello everyone, I am Niladri and I welcome you all for today's session. We are going to discuss about the PRACH design challenges and solution plus the placing of the reserved resources for the PRACH. So we'll start with the challenges first, then we'll see the solution and we'll see the field possibilities during the PRACH transmission and how the solution help us to get an interference-free PRACH transmission. So we'll start with challenges. There shouldn't be any interference in the uplink with PUSCH and PUCCH. This is challenge number 1. When we are transmitting the PRACH in the uplink, there should be no interference with uplink channels like PUSCH, physical uplink, SAD, channel and physical uplink control channels. Challenge number 2 is no interference with other PRACH in the same cell. Please understand, in the same cell we are in multiple mobiles. So we have 64 reserved preambles, orthogonal sequence. So there shouldn't be any interference with the other PRACH also in the same cell. This is own cell or the same cell. And the challenge number 3 is no interference with other cell in uplink. That means any other neighbor cell, there shouldn't be any interference. So these are the 3 major challenges and how to resolve this problem. So here's the solution. The solution is reserved time and frequency resources for the uplink PRACH transmission. So we have reserved resources in the frequency and time grid to avoid the interference with PUCCH, PUSCH and same cell other PRACH transmission and with the neighbor cells also. Though we are using different frequency shifts, that means different location of time and frequency resources for PRACH and the uplink control and SAD channels. So we do have a least chance of interference. Moving on, the fourth point is, or the fourth challenge again is uplink transmission should be time synchronized. Downlink transmission is already synchronized, so we have to ensure there shouldn't be any time gap in the uplink. The time synchronization should be there, must be there in the uplink, because we operate from different distances from the cell. You can just correlate with the near-far effect in GSM. So when you transmit from near to the E node B and little far, the signal reaches at the E node B with different time delays. So we need to ensure there should be, UV transmission should be time synchronized. That is one more challenge. And the fifth challenge which I can see is high probability of interference with the other channels even if there are time and frequency reserved resources. Though there is time and frequency resources reserved for the PRACH preamble transmission, even then there is a chance of interference. So how to get a solution for that? Thanks to LTE technology, we have guard timings in the PRACH preamble. So we transmit the preamble, we have a cyclic prefix and we have some guard timings. So that percentage, like how many time for, or what is the resource we are putting for the cyclic prefix, how much time or how much resource for the preamble and how much for the guard timing or the guard time, that we'll see in the next session. So we'll see the time delays, how the UV transmit and how different time delays reach the E node B and how the PRACH transmission is free from interference. So that we'll see in the next chapter. Today we are just focusing on the the challenges and the solution, and we'll see also the PRACH different formats. What are the different formats and how the resources have been divided between the cyclic prefix, the original PRACH preamble and the guard time. So that we'll see further. Now let's focus on the solution. So as you can see, for the above 3 challenges we have solution of reserved time and frequency domain resources for the PRACH preamble transmission, for the uplink time synchronization and high probability of the interference with the other uplink channels. We have introduced the guard time in the PRACH preamble itself. How to know where these resources are put in the frequency and time domain or the grid or in the spectrum, where they are located, how we transmit or how we reserve resources for the uplink PRACH transmission. So they are actually dynamically defined or dynamically placed. So there are two parameters, two RRC layer parameters, which give the information where they are getting transmitted and where these resources are reserved. So those two parameters are PRACH configuration index, first parameter, and the second one is PRACH frequency offset. So if the UE want to know these two RRC layer parameters, like how the frequency and time resources have been reserved for the uplink PRACH transmission, UE may get this information from the system information, these two parameters, PRACH configuration index and PRACH frequency offset, so that UE gets an idea on which resources or which time and frequency grid or which 6 resource blocks. We have 6 resource blocks for the uplink PRACH transmission. So 180 kilohertz into 6. So 6 resource block for the uplink PRACH transmission. And the time is 1 millisecond. So how they are placed in the frequency and time grid, that can be obtained by the UE from the system information. That is 2 RRC layer parameters. One is PRACH configuration index and the PRACH frequency offset. So this is very important topic, and I hope you really understood and enjoyed this topic. We'll be coming up soon with this new things, like how the time delay is defined with different distances trying to reach the E node V, and how this different configuration of PRACH helps us to get an interference free uplink PRACH transmission with unique preamble sets, like that 64 preambles that has been reserved for each of the E node V. Thank you so much for watching, and do stay tuned with the channel, and we'll be updating very soon the new chapters. Thank you so much. Do subscribe, like and comment, and don't forget to click on that bell button to get the notifications. Take care. Bye bye.